Welcome to my channel Fee Concepts CHM. This is the fifth part of the series of Introduction to Lasers, where we will see about the applications of lasers. You will find the applications of lasers in numerous fields. Lasers are used in mechanical working, industrial electronics, entertainment electronics, communications, information processing, in wars to guide the missiles to the target, in CD players, laser printers, laser copiers, optical floppy disks, optical memory cards, etc. So now we will see some important applications of lasers. First is welding. Welding is joining of two or more pieces into a single unit. So laser is used to melt the material on both sides of the joint. The molten material then mixes and resolidifies and then fuses its parts. So carbon dioxide lasers are used in welding thin sheets and foils. Advantages compared to the conventional methods: it is a contactless process. Hence, there is no possibility of introduction of impurities into the joint. The materials does not get distorted, as the total amount of input is very small compared to the conventional welding processes. Heat affected zone is relatively small because of rapid cooling. Can be done even at difficult to reach places. Next is drilling. Drilling is vaporization of the material at the focus of the beam. So the lasers, they can be used to drill holes as small as 10 micrometers in diameter. Ruby lasers are commonly used for this. Next is hardening. Hardening is a process which is done for some time to harden the metals and certain other materials. So here normally the metal surface is heated with the help of laser, and then we let it quickly cool down. It is commonly used in tooling and automotive industries. So the heat treating converts the surface layer to a crystalline state that is harder and more resistant to wear. So that improves the strength and the durability of the surfaces. Carbon dioxide lasers are used. Advantages: lasers provide selective treatment of the desirable areas. Again, it is a non-contact method. Next is electronics industry. So lasers are used in the manufacture of electronic components and integrated circuits. They have been used to perforate and divide silicon slices having several hundred circuits. They can be used for the isolation of faulty components in a large integrated circuit. Integrated circuit contains very small components, uh, and if you want to isolate the faulty components, that can be done by disconnecting the conducting paths by evaporation. This evaporation is done by the lasers, so that can be done very easily. Trimming of thick and thin film resistors using lasers is a very common application. Next, measurement of atmospheric pollutants. Now, understanding the Earth's atmosphere helps us in solving the growing issues of environment like greenhouse effect, ozone depletion, melting of glaciers, etc. The conventional methods of pollution measurements require that the samples of pollutants are to be collected for chemical analysis. Therefore, these methods they will not give the real time data. So we can use the laser methods which permit measurements by remotely sensing the composition of the atmosphere without the necessity of sample collection or chemical processing. So we can consider the lasers to be a very useful tool for the measurement of the concentrations of various atmospheric pollutants such as nitrogen, carbon monoxide, sulfur dioxide and gases and particulate matter such as dust, smoke and fly ash. So we have this system called as LIDAR, which is with the full form of LIDAR is light detection and ranging. These are the LIDARs are used. The LIDAR emits laser light into the atmosphere, which is reflected back to the LIDAR by the atmospheric particles. So the light detected is used to study the aerosols, the water vapor, the gases present in the atmosphere. Thank you for watching this video.